Hi guys, today we are going to bring you the BYD latest battery pack technology. It is the BYD 10C flash charging battery. The battery pack we tear down here is from BYD Han L sedan. So firstly, let's take a run at the battery pack and see its overall design. Here we can see the whole battery pack is a flat type design in a very compact and concise way. This battery pack looks like the BYD famous car Seal EV's battery pack that both adopt BYD CTB technology. But the Han L battery comes from the Super E platform, which is more advanced than Seal EV. CTB means the battery cell directly integrated with the vehicle body. There is no passenger cabin floor or the battery pack housing cover. That is to say, the cabin floor and the housing cover integrated as one component. For Han L, the top cover acts as the cabin floor. This is the same way Tesla 4680 battery pack uses. And now what we see here is the rear end of the battery pack. There is a larger BDU, the battery disconnect unit, located in the middle. At the left side, there are the venting valve and the pressure balancing valve. From the nameplate, we know the rated capacity, the rated voltage, so it gives the rated energy about 83.2 kilowatt an hour. And this yellow interface is HV connector to rear motor. And the right side also has the venting and pressure balancing valves. And these are the fasteners, so we can know how the housing cover and the housing tray are connected. You should notice that there is a gray strip, which is the gasket between the vehicle body and the housing cover. And from this view, we can see the side frame of the battery pack and its bottom plate. BYD uses the very innovative honeycomb structure to form its bottom plate. It is a multi-layer composite integrated with a steel plate. We will take a deeper insight to this bottom plate. There is a cooling pipeline located at each side of the frame. Some OEM like this kind of design. This arrangement is a space-saving and a more safer way for the cooling pipeline layout. So let's move to the front end of the battery pack. On the top of the housing cover, there is a light black mat and also a big white pad. So we can see the material of the light black mat is PO, and the material of the big white pad is MPP plus glass fiber. And there are 4 very large fasteners, which are the connected points between battery pack and vehicle body. Okay, now we are looking at the front end of a battery pack. Again, in the middle, there is the front BDU. At the left side are the cooling interfaces of the up cooling plate and the bottom cooling plate. We must know that here BYD uses the direct cooling technology, not the liquid cooling technology. And there also is a yellow interface, which is the HV connector to the front motor. You can see its design is similar to the rear HV connector. There are some blank plastic structure attached to the housing tray. This plastic structure has the function of keeping warm. And these are the fasteners for housing cover and front BDU. Also some new mechanical design of the front BDU. Also, we should learn that the up cooling plate is the housing cover they are integrated as one. So we should firstly remove the white pad. We can see the layout of the upper cooling plate and how its cooling channels are arranged. Let's move to another place to take a look at the white pad. And this is the inside face of the white pad. So the white pad is also a multi-layer composite design. In order to tear down in a safe way, we firstly disconnect the HV circuit. So we remove the rear BDU cover and the front BDU cover to disconnect the HV circuit. You can see the inner layout of the rear BDU. The rear BDU is a modular design. Also, it adopts a free busbar design, which means to use as less as busbars. We will take a deeper into the rear BDU design. Move to the front end. The front BDU has a lower integrated level compared to the rear BDU. But both BDU can be removed entirely from their cabins, which means the BDU can be replaced as a whole or its components can be repairable. You can see the hollow cabin structure, and there are some bus bars reach out from the inner of the housing tray. And the front BDU cabin is a similar design. And then we open the edge of the up cooling plate using pry bars. This will facilitate the volume removal of the entire cooling plate. Since there are many thermally conductive structure adhesive, separating the cooling plate from the battery cells is very hard. This adhesive makes the battery pack non-repairable. So after remove the upper cooling plate, we can see the overall layout of the battery cells. The cell here is a BYD short blade cell, while the cell EV adopts the long blade cell. There are 8 cell modular in total. The whole housing frame has 3 cross beams, no longitudinal beams, but there is a structure has the function of the longitudinal beam. And here we can see the main positive bus bar and the main negative bus bar. Their arrangement is in an extremely compact way. Then we disconnect the HV connectors between cell modulars. These are the modular low voltage connectors. You can see the green connectors. And these are the locations where bus bars are welded between modulars. And there are still some adhesives remain on the cell surfaces. Here are another kind of a glue, some porting glue between cell modular and housing frame. This is a unique design from BYD. And then we invert the whole battery pack and remove the bottom plate, which allows us to see the layout of the bottom cooling plate. The gray material is a structured adhesive, and there are also some aluminum plates. Some of these plates are solid, others are hollow. The functions of this plate include enhancing structural performance, providing protection from ground, and offering support to the bottom cooling plate and battery cells. These plates are connected to the housing frame and the cooling plate through methods such as adhesive bonding and the weldings. The 3-component housing frame, the cooling plate, and the reinforcement plate forms an integrated structure with excellent mechanical properties. This kind of design firstly applied in BYD cell EV. And then let's look at the removal process of the bottom cooling plate. We can hear the sound of the adhesive peeling off from the cell surface or the cooling plate surface. This adhesive is more difficult to remove than that of the top cooling plate or the up cooling plate. And at the same time, we should also note that the cooling plate is connected to the housing frame through friction stir welding. Therefore, before remove the adhesive, we should first cut off the friction stir welding. And then finally, we got separated the cell modules in the housing frame. We will tear down the cell module later and see how the cells are grouped. See you next time. Bye bye.